Hello, welcome to my channel. In this video, I'll be discussing Newton's law of motion. The first Newton law of motion is otherwise known as the law of inertia, and inertia simply means the ability of a body to continue to be at rest, the tendency of a body to continue to be at rest or to move in constant motion. That is inertia. Newton's first law states that an object will remain at rest or in uniform motion in a straight line unless acted upon by a net external force. You place a body on a table, let's say a book, that body will continue to be there until an external force acts on it, okay? Or it will continue to move in constant with constant velocity. That is what is known as uniform motion in a straight line. Okay, until an external force acts on it. That's the first Newton law of motion. You can watch my earlier video on motion, relative velocity, and Newton law of motion that I did earlier. I explained there is more explanation to this there. The second Newton law of motion states that the force when a body is at rest or in constant motion is acted upon by a force. That force is directly proportional to the acceleration that is experienced by that body. And what is the constant here is the mass A. Okay, if you apply different force to the same body, to the body of the same mass, the acceleration increases. Okay, and don't forget that acceleration is equals to v minus u over t from our equation of motion. You can watch my video on the equations of motion for you to have better understanding on equations of motion where I showed how it is derived. So if you substitute this in this formula, it will give us F equals to M brackets V minus U over T. Okay, and we can bring this T to this place to give us Ft is equals to M V minus U. And this Ft, the Ft here is what is known as impulse of the force, is what is known as impulse. While this mv, m, we can expand this formula and it will become mv minus mu, which is the mass of the body times final velocity minus the mass of the body times initial velocity. This is what is known as the change in momentum of the body. In other words, the second Newton law of motion tells us that the impulse of a force, which is the magnitude of the force, times the time, the duration of time the force acts on a body, is directly proportional to the change in momentum. As the change in momentum increases, so also the impulse increases. Okay, so impulse is equals to change in momentum. Please take note of this as you use it in the further discussion. Okay. So, like I said earlier, impulse is a product of force and the time interval over which it acts and is equal to the change in momentum. Let me explain this thing further. Let's say there is a ball on the floor like this. Okay. What this thing is trying to say is that if a force F acts on this body for a time duration of t, Okay, the change in momentum of this body, that is the mass, initial mass times final velocity minus mass times initial velocity. Okay, the product of this force Ft is equals to the change in momentum, which is mv minus mu. Okay, the first time graph visually represents how force varies over time. If you have F here and T here, time T, how the force varies over time. Let's say it varies constantly over time and it gives us a straight line. The area under this curve, what would be the area under this curve? Under this place. You see, this is a triangle actually, right? This is a triangle, right? And if the area of a triangle is 1 over 2 base times height, right? The base here is what? The T times height, which is the force. So if you look at this Ft, that is impulse, right? So the area under the curve of a force time graph is actually the impulse. That's the meaning of this statement. And the larger the area, the larger the momentum. The larger the area, the larger the impulse, and also the larger the momentum, because we know that the impulse is equals to change in momentum, right? So the larger the area, which is the impulse, the larger the change in momentum when a force acts on the body. The principle of conservation of linear momentum states that in a closed system with no external force, the total linear momentum remains constant. Let's say two balls are moving. This one, let's say, is M1. It has mass M1 and is moving at U1. And another body moving in the same direction, M2, U2. If this one come to collide with this, both of them can stick together and move in the same direction, right? With the same velocity, V. Okay? Now, this M1, M2. What this thing is clearly stating is that the total linear momentum, don't forget that momentum is mass times the velocity. The total linear momentum before and after are the same. That's what they mean by that it remain constant. Meaning that the momentum before, which is M1 U1 plus M2 U2, will be equals to M1 V1, okay, plus M2 V2. Okay, this is what the principle of conservation of momentum states. Okay, so take note of that as you'll be using it in the subsequent calculation. And also take note that if when you are doing this calculation, you have to take one direction as positive and the other one as negative. So both of them are positive because they are moving in the same direction. In a body that collide and move apart, you will take account of that. One direction will be positive and the other one will be negative. Let's apply this formula in some of these questions so that we can have better understanding. Question number one. It said a 5 kilogram bird object moves with a velocity of 10 meter per seconds. Okay. They said what is its momentum? Don't forget that momentum is equals to mass times velocity, right? And that will be 5 times 10, which is equals to 50 kilogram meter, 50 kilogram per meter, 50 kilogram meter per seconds. This is the unit of impulse or momentum, and it is the same thing as Newton seconds. You know why it is like this? You can watch my video on SI units and derivation of dimensional analysis to have a better understanding. Question number two. If the net force on an object is zero, which statement is correct? The object must be moving. No, that is not correct. It can be at rest. The object moves with constant velocity. Yes, is probably correct. The object accelerates. No. The object gains momentum. No. The object only accelerates when force acts on it. Okay. And it can gain momentum only when force acts on it. So the correct answer is B. A 5 kilogram body accelerates at 4 meter per second squared. What is the net force acting on it? The force is equals to mass times acceleration. This one is straightforward. Okay, I believe you should be able to do that. A bullet of mass 50 gram is fired at 400 meter per second. It embeds in a stationary block of mass 1 kilogram. Find their common velocity after the collision. Let's look at it. Let's say a gun is fired from here, right? And the bullet is shot, okay? And it hit a stationary block here. And when it hit it, both of them move forward with the bullet embedded in the block. Now, we know the mass of the bullet is 50 gram. We need to convert it to kilogram, okay? And that will be 0.05 kilogram, right? And we know it's moving at velocity of u is equals to 400 meter per second. And finally, both of them, when they came, they lodged together. Don't forget that this one has its own mass and this one has its own mass. So the mass of this one will be their combination, which is 0.05 plus 1, which is 1.05 kg. And they move. They ask us to calculate the common velocity v, which we don't know. Okay. In the principle of conservation of momentum, the momentum, the total momentum before is equals to the total momentum after. And the total momentum before, the block is 1 kg, right? And the initial velocity is 0. The momentum before will be the m1, which is the mass of this one, 0.05 times 400, okay, plus the initial momentum of this, which is equals to 1 times 0, which is 0 anyway, will be equals to the total momentum after, which is the total mass 1.05 because both of them stuck together, times the velocity that we want to calculate, right? So from here, we know that this 0.05 will be equals to 20, okay? And is equals to 1.05 V. V will be equals to 20 divided by 1.05, right? And if you press your calculator on, the answer is equals to 19.05. So this is the answer, okay? An object moving in a circular path at constant speed experiences A. No force. B. Centripetal force directed outward. That's not correct. The force that is directed outward is centrifugal. Okay. Centripetal force directed inward. This is correct. Gravitational force only. That's not correct. Okay. A 3 kg object is hanging from a rope. What is the tension in the rope? They said a 3 kg body hanging on the rope. We know that the weight of this will be 3 times 10, which is 30, right? Good. And the weight here will be equals to the tension here. Okay. So the answer is 30. A force 10 Newton acts on a 25 kilogram mass for 0.5 seconds. What is the change in momentum? We know the impulse is equals to change in momentum, right? So this is straightforward. 100 times 0.5, that will be 50 Newton seconds. A 2 kg object is moving at 6 meter per second. It collides with a stationary 4 kg object. After the collision, the 2 kg object is moving at this 1 meter per second. What is the velocity of the 4 kg body? The 2 kg body moving at 6, that is 2 kg moving at 6 meter per second, collides with another stationary body which is 4 kg. U is equals to 0. After collision, both of them move forward, right? And we know that the 4 kg, the 2 kg body is now moving at 1 meter per second. So what is the speed of the 4 kg body? That's what we don't know now, right? In the principle of conservation of momentum, momentum before, right, is equals to momentum after. And the momentum before is 2 times 6, right? 2 times 6 plus 4 times 0, okay, will be equals to 2 times 1 plus 4 times v. We know this will be 0, right? Good. So this will be 12 equals to 2 plus 4v, right? And this will be equals to v equals to 12 minus 2 over 4, right? Which is 10 divided by 4, right? And this is equals to 2.5. The answer is 2.5 meter per second. A 6 kg block is sliding down a frictionless incline at an angle of 30 degrees to the horizontal. What is the acceleration of the block? Let's say this is an inclination at 30 degree. They say a block is sliding down like this, right? They say what is the acceleration? For us to know the acceleration, we need to know the weight of the body, and we can know the weight by from the mass. We know that weight is equals to 6 times the acceleration to the due to gravity, approximately 10. Though you can use 9.8. Don't forget about that. So the weight of this body will be equals to 60 Newton, right? But you know, weight always acts vertically downward. Now, for us to get the component of this weight along the plane, we need to resolve it. You can watch my video on resolution of vectors for you to understand this better. It was discussed extensively there. I would advise that you watch it. Okay. Now, for you to know the components of this force along the plane axis, you resolve it. We know this is 30 degree, right? The angle here will be 90 minus 30, okay? And don't forget that if you say cos of 90 minus alpha is the same thing as sine alpha. So I will use sine 30 here, okay? So the force here, F, will be equals to 60 sine 30. And this is equals to what? This is equals to 60 times 1 over 2 equals to 30, right? So that is the force along this axis. Having known the force, we can now know the acceleration of this block here. Force is equals to mass times acceleration, right? And acceleration is equals to force divided by mass. And we know that the force is 30 divided by the mass, which is equals to what? 6 kg. So this is equals to 5, right? The acceleration is 5 meter per second squared, which is equals to 4.9. Don't forget that here, rather than using 9.8, we use 10. So if you use 9.8, you get 4.9. In a perfectly elastic collision, which is conserved, momentum only, kinetic energy only, these are not correct. Both momentum and kinetic energy, this is correct. In the principle of conservation of momentum and principle of conservation of energy, you can use it to explain this. I'll leave the remaining question for you to answer. Please kindly like, subscribe, and share this video for others to benefit from. Go through the questions. Write your answer in the comment section below. Let's open up discussion. Until I see you in my next video, take care and bye bye.